Nowadays we're doing a lot of collaboration through Innovate UK funding. We've had the opportunity to work with Jaguar Land Rover and Ricardo in looking at electric vehicles and traction motors for electric vehicles, which has obviously taught us a great deal about the requirements of that industry.
So what are the challenges there for us? It's simulating electrical machines in movement connected to complex circuits?
Yes. Well, the challenge that we have for the future, certainly, and something that we're looking to work on in the future through the same sort of integrated design program, is the whole connection of the electrical machine up to the gearbox, up to the complete drivetrain, and the vibration problems in particular that must result from the connection to the mechanical system as well. Yeah.
So even more multi-physics.
More
different simulations being required to complete the design.
Yes.
It's very exciting to include vibration and acoustics within opera.
Yes.
In addition to that extension of multi-physics, is more parallel processing development still needed? I mean, I guess if you're talking about modelling rotating electrical machines in 3D, that's still a significant simulation time for us.
I think so.
We need to make it run faster, better parallel analysis, better parallel solution of equations.
Faster solutions are always right, and this is perhaps one of the areas where we need to do more work, which is into reduced order modelling, and that's something that again we might be interested in doing in the future, I believe. Another area where I think we've got some interesting work ahead of us is to look at materials at different levels, so multi-scale modelling. We want to be able to understand what's happening in a superconducting coil, particularly if it goes to high temperature superconductors at the wire level, but we can't afford to really model the whole computation-wise. Even with all our wonderful parallel processing developments, we can't afford to be able to model at the wire level for a complete application like an MRI magnet, for instance, or another superconducting magnet.
But that's something the software is almost capable of doing at the moment, and I mean you're doing some tests on that with possibly bulk models of materials connected to individual models of wires.
That's something that I'm interested in doing. Certainly, we'll see. The jury's still out on that whether we can do this, but it's something that I'm certainly have got interested in doing. But multi-scale modelling happens in lots of other areas as well, doesn't it? If you look at thin magnetic films, they're so thin these days. They're down to the angstrom size almost, where you can no longer treat them as a macroscopic material. So you have to do something else about it. Or permanent magnets. We know that permanent magnets have got magnetic domains inside, but we don't really model at domain level yet. And would people be able to get more out of their magnet material if we could actually give them those sort of tools?